Good morning. This is Mr. Burns, CPVLF science instructor, and it is Monday, March 12th, and I'm bringing you the 27th chemistry launch of the year. Isn't that something? We've been through 27 of them now. Well, and spring is on its way. I know it's cold out there and there's snow and all of that, but I have to keep believing that too. I probably have as hard a time as you do with that, and just very much looking forward to it. Okay, I hope all is going well in the course. Right now we're getting lots of work is being done. I like the quality of it too. A lot of balanced equations and redox reactions and concentration of reactants and products and dynamic equilibrium reactions and all sorts of things like that. So keep up the good work. Keep it coming. We want to see you be successful all the way to the end of the year. Okay. Let's review what we did for last week. Last week you took quiz 3. That was a toolbox to titration, 215, and redox equilibria, 216. You did redox and oxidation potentials, 217. You did activity, solution concentration versus conductivity, 218. And you did one called pH calculations, 2.19. Now this is more complex material, there's no doubt about it. A couple of hints, titration. In titration, you are measuring the concentration of the materials, one material against another. You have a known material, and you're measuring the concentration of an unknown material against it, and it's done with colors, okay? Most of you got that right in the reflection question. I was glad to see that. Redox reactions. Okay, remember, those are the reactions that show the exchange of electrons between a positive side and a negative side. They're showing how a cation can become more or less positive and an anion can become more or less negative. Remember the phrase, Leo says grr. Okay, that's what I do to keep in mind what's going on there, which is which. Leo is LEO, and that means loss of electrons is oxidation, and GER is GER, gain of electrons is reduction. Now here's a real mind game for you, mind twister. If something is oxidized, then it is a reducing agent. So if I find the loss of electrons proves that something's oxidized, that's the Leo. It is also the reducing agent. Okay, and the other way around, if I use the GER and I find out that something is reduced, so I got a gain of electrons and it's reduced, it becomes the oxidizing agent, okay, within the equation that you're dealing with. That can be very confusing. It's something you just need to practice to learn. But because you're going to be asked, what is the reducing agent? What is the oxidizing agent? Well, that just means what is being oxidized and what is being reduced. Okay, then you also did this solution concentration versus conductivity that had to do with the amount of ions in solution and you know what the conductivity was compared to the amount of ions that were there. The more ions, obviously, that were dissolved in solution, the more conductivity. Once the ions made a precipitate, a solid, then you had less conductivity. That's what was going on with that one. pH calculations too, another area where you have to calculate things. The pH, remember pH is a measure of the hydrogen ion concentration in a solution. So what you're doing is figuring out how great the hydrogen ion concentration is. There's also what we call pOH, and that's determining the hydroxide ion concentration in solution. Okay, if you have any questions on those things, be sure to let me know. I want to see you be successful on that too. Okay, let's look at what's coming up for this week. For this week, we're going to do a lesson called Organic Compounds 3.1, Sources of Organic Compounds 3.2. You're going to take a quiz. It's quiz 1, Carbon Compounds 3.4, and another lesson called A Closer Look at Carbon Atoms 3.5. If you need any help with any of those, please let me know. I want to see you be successful, as I keep saying. Okay, our reflection question for the week is, what element must an organic compound have in order to be considered organic? I'll say that again. What element must an organic compound have in order to be considered organic? Okay, that's it for this week. If you need anything, let me know, and I'm sure we'll be talking again. So have a great week. Bye now.